This video goes with the guided notes equations of perpendicular lines. We're going to be finding the equation for perpendicular lines in this lesson. It's exactly the same as working with parallel lines. The only difference with perpendicular lines is that we know perpendicular lines are going to make a right angle. Now, when we were doing parallel lines, we said, well, parallel lines, the slopes are the same. But that can't be true for two lines that make a right angle. What is true is the slopes are the negative reciprocal. And that is right up here. The slope of perpendicular lines are negative reciprocals of each other. Okay, an example of perpendicular slopes would be 3/4 and -4/3. Notice I took the reciprocal, but also changed the sign. Now, if you start off with a negative slope, something like -1/7, its perpendicular slope would just be +7, or we could say 7/1. Okay, now, when we do this, we have three ways they're going to give us our information. The first way is they could just tell us the slope and the y-intercept, and we could just use straight out y equals mx plus b. If they tell us this slope, but they tell us another point that's somewhere on the line, we'll have to use your point slope formula. Or if we are talking about lines that end up being vertical or horizontal, we have to refer back to Hooy-Vuk's. Okay? So now let's look at example 1 and see how this is going to work. And again, it's so much like the parallel. So example 1 says, find the equation of the line that is perpendicular to y equals 1/2 x plus 6 and has a y-intercept. I'm sorry, 1/2 x plus 3 and has a y-intercept of 6. Well, we know that since the slope of our original line is 1/2, I'm going to have to take the negative reciprocal of that. So that would be -2/1, but I'm just going to make it 2 because I don't need that one denominator. So my slope is -2. Now, I've been told that the y-intercept is 6, so that means B, because we know that's the symbol for y-intercept, B equals 6. Okay, well, since I know my slope and my y-intercept, I can go straight to y equals mx plus b, and I've got y equals, substituting my two numbers in, -2x plus 6. And there's my answer. Okay. Now, number 2 is going to be an example that's going to require us to use the point slope formula. Okay, so if I come over to number 2, it says, what is the equation of the line that is perpendicular to y equals 3x plus 4 and passes through the points -3, -2? Well, we have our x(1), y(1) for our formula right there, but I need my perpendicular slope. So I'm going to write right here, m equals. Now my slope up here, my original line is 3, so I need the negative reciprocal of that. So the reciprocal of 3 is 1/3, and I got to change the sign, so I'm going to make it a negative. Okay? Now I have my 3 numbers to put into my formula, so let's write the formula down. Y minus y(1) equal to m parentheses x minus x(1). So that's y minus -2 equal to -1/3 parentheses x minus -3. Now, there's a lot of minuses and negatives running around there, so let's go ahead and simplify that, because you know minus a negative is adding a positive. So y plus 2 equals 1/3 x plus 3. Now, let's go ahead and get rid of our parentheses. y plus 2 equal to 1/3 x. Now, 1/3 of 3, you know that. If you take 1/3 of 3, you're going to get 1. Okay? And then the last step would be to subtract the 2 over to the right side. So I've got y equal to 1/3 x, and then 1 minus that 2 is going to be minus 1. And there is my final answer. Now, the last two examples, just like with the parallel notes, are going to be talking about Hooyvukst. Okay, so if I look at example 3, it says a line is perpendicular to x equals 4 and passes through the point -2, 4. What is its equation? Now, I want to just sketch this for just a second so we can see what's happening. Again, a picture is worth 1,000 words. If you're not sure, make a picture of it. A lot of times you can actually solve a problem just by looking at the picture. Okay, so I've got x equals 4. 1, 2, 3, 4. And I'm going to draw in. Now that's x equals 4, and Hooyvukst says that should be a vertical line right there. Now, I need to find a line that is perpendicular to that that's going to go through the points -2, 4. So if I find the point -2 and 4, that's going to be right up here, isn't it? Now, I want it perpendicular, so it's got to make a right angle. So if I draw it in so that it makes a right angle, and see, I see my right angle right there, I don't have a vertical line anymore. I have a horizontal line. Now, that means horizontal means the equation I'm looking for is going to be a y equals. Well, the number that y is equal to is, remember, the y coordinate of that ordered pair. The y coordinate of that ordered pair right here is 4. So the line y equals 4 will be perpendicular to the line x equals 4. Okay? Now, example 4 is the same thing with horizontal and vertical lines, just going to be flip-flopped. You'll see what I mean by flip-flopped. So if I go to number 4, it says, what linear equation represents the line that is perpendicular to y equals 3 and contains the point 5, -2? So if I draw my axis right here, okay? Now, it says I have the line y equals 3, so that means I'm going to go up here to 3. 1, 2, 3, and I'm going to make a horizontal line because we know y equals in Hooyvukst is horizontal. Now, I need to find a line that is perpendicular to that, but will go through the points 5, -2. So if I find the point 5, -2, right here. Now, if I'm going to make that point perpendicular, it's got to be vertical, don't it? So that it makes that right angle. And that is a vertical line that goes through 5 on the x-axis. So the equation for this is x equals 5. Okay, so what we've just gone through are the 4 ways that they can give you these problems. One using the slope-intercept form, one using point-slope equation, and one of each type of Hooyvukst. Okay, that's all there is to perpendicular lines.